Okay, so hopefully you'll be able to look at this. This is financial maths. I'm going to start with financial maths because we really need to move on, and I don't know how long this snow is going to take. So to start with the basics, if you want to add a certain percentage onto a number, so if you want to add 5% onto a number, that means that you want to get 105%. Okay, so to add 5% on, we need to find 105% of the number. So if the number is P, to find 105% of a number, you multiply the number by 1.05. Okay, to get 83% of a number, you multiply the number by 0.83. To get 12.5% of a number, you multiply the number by 0.125. To add 12.5% onto a number, that means you're finding 112.5%, which means you multiply by 1.125. Okay, so to add I% onto a number, you must multiply the number by 1 plus I as a decimal. I as a decimal means the percentage divided by 100. The example here, to add 5%, you multiply the number by 1 plus 5% as a decimal, and 5% as a decimal is 5 divided by 100. So that's how you add on a percentage to a number. Okay, now, therefore, and we would have done this for junior cert, if you want to put so much money into the bank and the interest rate is I, okay, then at the end of 1 year, the bank will add on that interest, that percentage onto your number. So at the end of the year, you're going to get P times 1 plus I over 100. I being the interest rate as a decimal. To convert the percentage rate to a decimal, you divide by 100. After 2 years of compound interest, that means going into the second year, you have 1 plus I over 100. So coming out of the second year, you have what you had going into the second year multiplied again by 1 plus I over 100. You are adding that percentage onto now this new number. And again as the years go by. So as you can see, after 1 year, you have P times 1 plus the interest rate as a decimal to the power of 1. At the end of 2 years, you have P times 1 plus the interest rate as a decimal to the power of 2. And at the end of T years, you will have P times 1 plus the interest rate as a decimal to the power of T. Now that should be no surprise, we would have done that before. Okay, now there are two things I'd like to look at now in terms of being able to calculate the present value and the future value of a sum of money. So if I have a sum of money P at the moment, then if there are regular interest, if there's regular interest paid over a certain time frame, and each interest rate is I%, hopefully you can agree that the future value of P, more or less said it in the last explanation, the future value of P is P times 1 plus I over 100 to the power of the number of time frames that you want to look into the future to see what it's worth. So if you put P into the bank and the bank gives you I% every year, at the end of, we will say, T years, your future value of your P will be P times 1 plus I over 100 to the power of T. It isn't always years. Okay, I'm referring to years here, but it can be after 12 months if your interest rate is being paid every month. So T will be the number of time frames. Now, the opposite side of that is if I have a particular value, an amount A in the future, and I am here at the present, and I want to know what is the value of that A in the future, what is the value of that back here now in the present? Okay, so to find the future value, if I call what I originally put in P, then after T number of years, I know that this A is P times 1 plus I over 100 to the power of T. Okay, so if I want to find what's the present value of that number in the future, what's its present value right now, and there is a reason for this, its present value, P, will be A divided by 1 plus I over 100, the interest rate as a decimal, to the power of T. So in other words, if you just take this equation here and divide both sides by 1 plus I over 100 to the power of T, you get P is equal to A over 1 plus I over 100 to the power of T. That's how you work out the present value of something. Okay, we need that when we're working out mortgages. Okay, now, I want to talk about if you are saving for a holiday, or you're wanting to put a fixed amount away at a regular time intervals, so that sometime into the future, after so many time intervals, you will have a particular sum of money. Okay? We can call that amount of money H, say for your holiday fund. So you've got a holiday, you know that in a year's time you're going to have to pay a certain amount of money for that holiday. You want to put away regular installments, regular amounts in a regular time frame, so that at the end you will have H for your holiday. Now that can also refer to a pension. So you want to put sums of money away regularly while you're working, so that when you reach a certain age, after so many of these time frames, you would like to be able to collect your pension. So you can decide what the pension is that you want to collect, and you then figure out what are these S's that will allow you to have that pension or that holiday fund at the end of what we'll say is N time frames. So N is the number of time frames. Okay? Now, remembering that for each, once you put the S away here, if you put that into the bank are going to give you interest on that every time frame. So that particular S, the first S that you will pay, will earn interest every time frame. Okay? So what we need to do is we need to say, well, get an expression for the pension in terms of all these S's added together. And that will be the sum that you will get at the end. So if we assume that you start at this point here, this is now, this is your present, and you will put away S after one time frame. You will then put S again in the same time frame once that time frame has passed, and you will then put S in again. Okay, and you're going to do that for N time frames. You now need to look at the value that this particular S will have. We'll put the very last S in here. Okay, so we'll put the very last S in here. So basically, this S is the last time frame, the last payment that you're going to make. And within one time frame, that S is going to be worth S times 1 plus the interest rate over 100, because that's going to have earned that time frame's interest. The S before that will have the interest rate, will have an interest rate added 2 times, okay? So the value of that S will be the S times 1 plus I over 100 to the power of 2. Going all the way back, this S, okay, which will have been in for N time frames, will have the value of S times 1 plus I over 100 to the power of n. Okay, this one, if you wanted to work it out, would be s times 1 plus I over 100 to the power of n minus 1, because it will have been in through n minus 1 time frames. So to work out what your s would have to be to give you a particular pension, you need to look at the sum of all of these values and put them equal to the holiday fund or the pension that you want. So what you want to do is you want to say that s times 1 plus I over 100, the top one, plus s times 1 plus I over 100 to the power of 2, plus dot 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 s times 1 plus I over 100 to the power of n has to be equal to your holiday fund or your pension. Okay? That, hopefully you will recognize that that is the sum of a geometric series. And it's a geometric series whose first term, T1, is s times 1 plus I over 100, and whose r, the multiplying factor, what are we multiplying by each time? If you look at this, we are multiplying by 1 plus the interest rate over 100 each time. And we have n terms. So to figure out what, another way of writing all of this is the sum, Sn, of that geometric series. And Sn of that geometric series is a times 1 minus r to the power of n over 1 minus r. Okay, so I'm going to rub out the top bit now. I'm going to start from the top down. Okay, so that's our expression. So we're now going to find an expression for the sum of that geometric series. So Sn is a times 1 minus r to the power of n over 1 minus r. Okay, tidying up a little bit, that Sn would, now the Sn, remember, refers to our holiday fund. So that's the amount that we want to save to have at the end of the n installments. So our holiday fund or our pension is s times 1 plus, now I'm going to, instead of writing I over 100, I'm going to call it the interest rate as a decimal. So you should be aware that I over 100 means the interest rate as a decimal, times 1 minus 1 plus interest rate as a decimal to the power of n over 1 minus 1 plus the interest rate as a decimal. H is equal to s times 1 plus I as a decimal times 1 minus 1 plus I as a decimal to the power of n over, now that just becomes 1 minus 1 minus the interest rate as a decimal. So that 1 take away 1 is 0, so we have minus the interest rate as a decimal. Multiplying across, we get minus the interest rate as a decimal times h is equal to s times 1 plus the interest rate as a decimal times 1 minus 1 plus the interest rate as a decimal. So s is equal to minus the interest rate as a decimal times h over 1 plus interest rate as a decimal times 1 minus 1 plus the interest rate as a decimal to the power of n. Whoops, that should be to the power of n. Okay. So that's your way of working out the S. So that is the S that you would be putting away on regular installments for N installments in order to get this H out. So if you want a pension of a certain value, you put in the value of the pension that you want. You put in the interest rate that the bank are going to offer you for putting your money away in the bank as a decimal. You put those into that formula and in here. And basically, that's how you can work out your S, the regular installments that you need to put away in order to have that holiday fund or that pension at the end. Okay? If you like, you can multiply the top and the bottom of that by -1. Now, if we do that, you don't need to, but just to tidy it up, and quite often you might be asked to put it in a certain format. If we multiply the top and the bottom by -1 to get rid of this minus, okay? So if we multiply that, sorry, there should be another count, by -1, on top we are going to get H times the interest rate as a decimal over, now, we can multiply the -1 by this, and then the answer by this. So, we'll put the 1 plus the interest rate as a decimal, as it was, and if we multiply the -1 in here, we get I'm going to put -1 times a minus gives me a plus, so we're going to get 1 plus the interest rate as a decimal to the power of n. That by that, and then we have a -1 here, like that. And again, you can just fill in your values for the interest rate and the holiday fund that you require. The N, of course, is how many installments you're willing to pay that over. Could be how many months or how many years. And that will give you the S that you need to put away on a regular basis so that you get that holiday fund or that pension. Okay, I'm going to pause the video now because I don't know how long it'll take to upload, and I'll put a